So in my previous video, I ran a Poisson regression, and we had our predictor variables, verbal ability, avoidance, sex, and mode of transportation, all as predictors of no-shows or client no-shows at a community mental health center over the span of 3 months. And so the next thing I want to show you is how to carry out a Poisson regression. So if we, to do this, we will click on Analyze, go to Generalized Linear Models as we did in the previous video, and I'm going to go ahead and just take these off here for right now. And you'll notice that we have an option for negative binomial with log link, so we can click on this. And what's going to happen is SPSS is actually going to adopt a default dispersion parameter value, which is equal to 1. And so that, like I said, that is a default in SPSS, and I'll show you how to request a dispersion parameter that's perhaps a little bit better calibrated than just adopting a value of 1. But for the time being, we'll go with the defaults. So we have negative binomial with log link. Our response variable, again, was no-shows. Our predictor variables included our covariates, verbal ability, avoidance, personal disclosure, and sex. We had mode of transportation as our predictor variable, and we had selected descending in order to capture essentially the reference category would be the group coded 1, which were those individuals whose primary mode of transportation was personal. Under model, we'll have all our predictors as we had in the previous video. Statistics will keep the exponential parameter estimates highlighted, and so really pretty much everything is exactly the same as what I showed you in the previous video. The only difference is that we're using negative binomial with log link. So we're going to click on OK, and looking at our output, you'll notice that much of it looks very similar to what we had previously. You'll notice in this case it says probability distribution is negative binomial, and the link function is still log. When we scroll down, you'll notice once again that we have our omnibus test, which is a test of whether our full predictor model is a significant improvement over our null model. Again, if our p-value is less than or equal to our alpha level criteria, which oftentimes is 0.05, so if we'll just say if p is less than or equal to 0.05, then we would reject the null, and we would conclude that our full predictor model is a significant improvement in fit over the null, and that seems to be the case in here. Now, as we, the thing to kind of note here is that, if we had a problem with overdispersion, the objective of the negative binomial regression model is to correct for that overdispersion, and what that oftentimes does is it makes our test more conservative. So if we compare what we had in this current analysis, in terms of our likelihood ratio chi-square and significance level, if we want to compare this against the previous Poisson model, you'll notice that with our previous model, we had a larger likelihood ratio chi-square value, and the significance level was actually, less than 0.001. So you can see right away that we have a little bit more conservative situation in this particular analysis. But nevertheless, we are able to reject the null hypothesis that and conclude that our full predictor model is a significant improvement over the null. If we look at the individual parameter estimates, the adjustment that we see is made down here. This is where it says negative binomial. This right here, this is where our dispersion parameter is located, and this is essentially the default that SPSS is giving us. So what this essentially is going to do is it's going to adjust our standard errors and actually make our tests of the individual regression coefficients more conservative. So looking at verbal ability, you know, in terms of interpreting the regression coefficients, we would interpret them basically the same way that we would with the Poisson regression. So we would say for every 1 unit increase on verbal ability, there's a predicted decrease of 0.076 units or log counts units on the dependent variable. So essentially, we have a decreasing number of no-shows for every increase in verbal ability. Now, was this statistically significant? The answer is no, it was not. Our p-value is certainly greater than our conventional criteria of 0.01 alpha level, so we would not reject a null when it comes to verbal ability. If we look at avoidance, we would interpret this to mean for every 1 unit increase on avoidance, there's a predicted increase of 0.072 in terms of the log count for no-shows. And was this statistically significant? The answer, again, appears to be no, as our p-value is greater than our alpha level. For sex, we see consistent with our previous analysis that essentially females were exhibited a lower log count on the number of no-shows as opposed to males. But again, this predictor was not statistically significant as well. So none of our predictors in this analysis right here were statistically significant. And the same goes for our dummy variables. We had dummy variable 1, so this is D1, and D2 right here. So we can see right here that essentially those people that were in the public transportation, when we compare it against the baseline, which is personal transportation, the log count for those in the public transportation was about 0.593 units greater than those in the personal transportation condition or situation. But that difference was not significant. When we look at those individuals whose primary transportation was other as compared to the baseline personal group, we can see that the log count was about 0.416 points higher on average than those in the personal condition, and the difference though was not statistically significant. So overall, we see that none of our predictors were statistically significant in this particular model. And if we want to go back and compare against what we had previously, you can see right here that with our Poisson regression, you can see that we had at least our avoidance and sex variables were significant. Our first dummy variable was near significant, but the negative binomial regression essentially, through the use of the dispersion parameter, increased the size of the standard errors and made our significance tests more conservative. Now, it's going with defaults is okay to a point, but the fact of the matter is that we might want to have a little bit better calibrated dispersion parameter than sticking with the SPSS defaults. And we can actually do this by again going into our generalized linear models box, and we can leave everything else exactly the same, but instead of clicking on negative binomial with log link, we can click on custom, and we can click on negative binomial, and the link function will be the log link. And the default value that you see right here, that's already included, is exactly the default value that we saw up here. So it's exactly the same. So, and we don't really want to go with that. We want a dispersion parameter estimate that is a little bit more accurate, because essentially, what we may have done is overcorrect the standard errors for each of our regression coefficients and made the test too conservative, by assuming a greater amount of overdispersion than there really is. So in order to have a better calibrated dispersion parameter estimate, we can click on Estimate Value. And so in this case, SPSS will estimate the dispersion parameter and then essentially make the corrections to the standard errors reflecting this particular estimate. So if we click on OK, now you'll notice that when we go down to our omnibus test, you can see that again, it is statistically significant. You'll notice that the chi-square value is actually higher than what it was in the previous analysis where we adopted the dispersion parameter of 1. Our significance level is 0.001, which is clearly less than the 0.05 that we had specified. In terms of the parameter estimates, we can see down here, this is the dispersion parameter, or basically SPSS is calling it an ancillary parameter, which was 0.121. Now the thing to note is that the dispersion parameter that in SPSS, if it is actually equal to 0, then it is actually what this translates into is that our data is following a Poisson distribution. So a dispersion parameter that's equal to 0 in SPSS would be the same value as what would equal the dispersion in a Poisson distribution. So if this was actually 0, then our regression analysis results would essentially mirror the Poisson regression. But we do have a value of 0.121, which is certainly greater than 0, meaning that there is evidence of overdispersion in our data. So when we make that correction, you can see that when it comes to verbal ability, we still see that it was not statistically significant. But when we look at avoidance and sex as predictors, you can see that both of these values were statistically significant. So essentially, when you compare these results against the results where the default SPSS dispersion parameter was 1, you can see that previously we overcorrected the model based on that default value, and it essentially made our test too conservative. So that's really an important thing to note. That's one of the reasons why just sticking with defaults can be so problematic when you're running different statistical packages. So another thing to note too is, as I said previously, when it comes to assessing fit, we can actually assess comparative fit using these global fit values. And we saw with the Poisson regression, we had an AIC value of 172.133 and a BIC value of 182.267. So 172 versus and 182. Now let's see what happens when we had utilized the default SPSS the default SPSS dispersion parameter of 1. You'll notice, well, let's clean that off, that the AIC value was actually higher as well as the BIC value. So in other words, when we utilize the dispersion parameter value that was set to 1, the fit actually is worse with the negative binomial distribution. So in this particular case, if I was making a comparison between the Poisson distribution and negative binomial distribution with a dispersion parameter equal to 1, then I would select the Poisson distribution results as representing a better fit to the data. Now let's see what happens when we compare against our model where we estimated the dispersion parameter. And you'll notice here that the AIC value is 173.121. The Bayesian information criterion was 184.943. So clearly these values are less than the values that we had for the model where we had assumed a dispersion parameter equal to 1. So this particular these fit statistics, when we compare against the previous negative binomial model, this actually indicates that our model is a better fit than our previous negative binomial model. And then, but kind of going back and looking at the original Poisson regression results, it was 172 and 182, and comparing here, we had 173 and 184. So actually, the fit of this particular negative binomial model was just slightly worse than the Poisson regression results. So, if I was selecting which result to kind of go with in terms of my preferred model, then I would probably stick with the Poisson regression results. But for the most part, I think it's highly important to understand that essentially our Poisson results and our negative binomial results that are where we estimated the dispersion parameter are largely the same. And in fact, you can again see that the dispersion parameter here was pretty darn close to 0. So the amount of adjustment made by including the dispersion parameter was really quite small. But sometimes it can be the case where you have a situation where you have a much more substantial dispersion parameter, like that would be estimated, and by including that dispersion parameter, it can actually fit better than the Poisson model. So at any rate, this was just sort of just to kind of illustrate the differences in fit between the three models. And like I said, you can use these goodness of fit values, particularly the AIC and BIC, to compare the fit of different models that have different predictors in them, as well as different values on the dispersion parameter. One final thing that I want to mention in this video is kind of going back to the predicted values and the deviance residuals. If you want to kind of take a look at your data and see if there are any cases that might be having an undue influence on your regression results, whether you're dealing with using Poisson regression or negative binomial, you can use these values right here and essentially create a scatter plot. So I'll do that here. This is just the mean response and mean predicted values and deviance residuals from the Poisson regression that I ran earlier. And so you can just put your predicted values along the x-axis, your deviance residuals along the y-axis, and you've got your scatter plot, and you can look for cases that appear to be sort of departing from what all the other cases are doing, and giving you the and possibly having an undue influence on your results. So I'm not going to go too far into that right now. Just highlighting that this is something that you can do in terms of looking for influential observations. One other way in which you can look for influential observations is to request Cook's distance. I'll just kind of show you that really quickly using Poisson regression. Again, you can utilize this using negative binomial as well. But previously we'd asked for predicted mean values and linear predictors and deviance residuals and so forth. But also we'll click on Cook's distance, and essentially influential cases would be those that have a Cook's distance value that is say greater than 1. So obviously in this case right here, we don't really have any cases where there's that apparent situation occurring. But all things being equal, larger Cook's distance values, as you depart from 0, indicate an observation is more influential on the results. But again, none of these values have a Cook's distance value that is greater than 1. So So we might say then that none of them has a particularly undue influence on our regression results. Okay, so that concludes this discussion of Poisson and negative binomial regression using SPSS. Hope you found this helpful.